Hello, welcome back to my channel. Today we will be looking at question 1 in homework 9, the ladybug question. So for part A, we are asked to find the angular speed of ladybug 1. The angular speed for ladybug 1 will have the same angular speed as ladybug 2 since they're on the same rotating disk. They're both rotating at the same angular velocity, so if we're assuming that's the disk and it's rotating at an angular velocity w, we don't know what value it is. Everything on the inside from the center of rotation, we're assuming that is the center of rotation. Ladybug 1 is here, and ladybug 2 is here. They're both rotating at the same angular velocity w. So for this option, for this question, it would be this choice. It would be the same velocity. Part B asks for the ratio of the linear speed of ladybug 2 to that of ladybug 1. Now, linear speed is not the same throughout a rotating disk. Angular velocity is equal to v over r. If we solve this for the linear speed or the tangential velocity, so the tangential velocity would be something this and this. They would have different values. So we're saying that is v1, that is v2. For the angular velocity of both of them, they're the same. So we could set them equal to each other. So if we use this formula, we know that the angular velocity is the same for both of the ladybugs. So the angular velocity so v1 over, if we assume that this entire length is L, and then the length from the center to 1 is L over 2, because the problem says that ladybug 1 is halfway between ladybug 2 and the axis of rotation. So if we did this, then this would also be L over 2. So ladybug 1 is halfway in between ladybug 2 and the center. So then this R value for ladybug 1 is L over 2, equal to V2 over L, because ladybug 2 is at the edge of the disk, and we'll just say that's L. Solving this out, we get V2 is equal to 2V1. Just moving things around, you would get that question. So the ratio of the linear speed of ladybug 2 to that of ladybug 1 would just be 2. Part C asks for the ratio of the of the magnitude of the radial acceleration of ladybug 2 to that of ladybug 1. Radial acceleration is also known as your centripetal acceleration. So if you were to look at the equations, if the relationship AC is equal to angular velocity squared is equal to R. From this equation here, we know that angular velocity is equal to V over R, or tangential velocity over the radius. So V over R squared equals R. You get V squared over R. Now, They asked for the ratio between the radial acceleration of Ladybug 2 to that of Ladybug 1, and they want it in form of a2 over a1. If we solve for a2, we would just plug in our values, our v2 squared over r, which is just L, so that's L. And then a1 for Ladybug 1 would just be v1 squared over L over 2, because it's halfway. v2 is equal to 2v1, so if we plug that in, we would get 2v1 squared over L, which is equal to 4v1 squared over L. Now, if we did a2 divided by a1, we would do 4v1 squared over L over v1 squared over L over 2, which then would simplify out to just 2, because this would cancel out with that, your L's would also cancel, and your 2 would go in the denominator, so it's just 2. Part D is asking for the direction of the vector representing the angular velocity of Ladybug 2. If the disk is currently in this coordinate plane, somewhat like that. It is rotating this way using right hand rule. You curl your hand in the direction of where the disk is spinning, so you would curl it this way. You would curl it in the direction of where the thing is rotating, so you would curl it that way. And then you can see that your thumb would show you where the direction of the angular velocity is. So in this case, it would be plus z. If it was rotating the other way, if the disk was rotating in the other way, it would be negative z for your angular velocity. Part E asks for the direction of the tangential component of the acceleration of Ladybug 2. Redrawing the schematic, you have a circle, and Ladybug 2 is here. It is spinning this way with angular velocity w. It's decelerating, so that means that its acceleration value would be somewhat towards this way, assuming that's your deceleration. Angular acceleration, it would be counteracting where your angular velocity is. So that means that your tangential velocity should also be pointing approximately that way. So in this case, it would be pointing in the negative y direction. So the tangential component of the acceleration on Ladybug 2 is the negative y direction.